0.1 meter. Okay, so the uncertainty is 0.1. Is it clear or not?
Okay.
So that is the uncertainty. And if it is measured along the x-axis, that is delta x. It can be measured along the y-axis, that is delta y. So delta x, delta y, right? So that is the uncertainty in position. And because the position is uncertain, you cannot figure out the velocity also. There will be uncertainty in velocity. It is not because of our compulsion, it is because of the wave nature of the particle. And when you multiply, so Heisenberg gave the formula for uncertainty, product of uncertainty into position and momentum will be at least equal to h upon 4 pi or more than that. If we want to find the minimum uncertainty, we can keep it as equal to. Got it? Is it clear?
So we'll only use the equal sign when it's mentioned in the question
Yeah,
minimum
yeah, minimum.
uncertainty.
Yes, you are going to find the minimum uncertainty because it can be more, much more. You can have the values, right?
So if it's not mentioned, then we have to use that symbol.
Yeah, because in all the cases you have to use it equal to, right?
Okay.
Equal to sign. And so we did some calculations with that. And now there is a new thing, new approach. We need to rectify the Bohr model. And we are moving toward the quantum mechanical model of the matter. Okay, quantum mechanical of the model of an atom is basically everything is quantized. Okay, quantized means because of the wave nature. Okay, the energy is quantized. Okay, because
So
the
what do you mean by
electron
quantized?
quantized means it is just like suppose we are using rupee as the smallest denomination is 1 rupee today. Okay, so if you want to pay somebody in a physical manner with the help of currency in India, I can pay in multiples of 1 rupee. Got it?
Okay.
So that is not I cannot pay 1.1 rupee. Is it clear or not?
Yeah.
Because now we are not having that 0.1 rupee. So that is changing in terms of quantum. Quantum means something is changing in multiples of some value. Why something is changing in multiples? Because a wave nature is there. We have seen wave nature, right?
Yeah, it's always more.
Yeah, wave nature is there. So because of the wave nature, what was there? But because of the wave nature, actually, you can
We
make
can't
out that.
figure out the position of the electron.
Yes, and also when there is a, because you need to complete the number of waves, any orbit is not possible. That also we have seen. The circumference of the orbit should be such that it should hold some whole number waves. Because complete waves, either one wave, two wave, three wave, okay, complete wave. This kind of orbit, the circumference is not permissible. So because of the wave nature, you need to put complete waves, four waves, five waves, three waves, okay, in the whole circumference of the orbit. This is the wave of the electron. And that puts the limit on the circumference of the orbit. It should be in the multiple of lambda. 2 pi r equal to n lambda, and when you cross multiply it, you're getting mvr equal to nh upon 2 pi. Okay, and actually that was the quantization of angular momentum. So it is because of the wave nature, not any orbit can be selected, only those orbit where it is integral multiple that can be selected. Got it? Is it clear or not?
Yes.
So everything will change as per the quantum theory. So the whole concept of orbit is now ruled out. This is the orbit. Electron, the board told us that the electron is moving in a orbit of fixed radius, fixed velocity, fixed position. Okay, now that is not permissible because the electron is not a particle, it is a wave, and because it is a wave, it doesn't have a fixed position. Is it clear?
Yeah.
Its position is actually spread around that. Okay, and the wave actually normally we draw it this way. We draw wave like the wave which we have in a rope. If I hold a rope and just move it one end with my hand, it will generate waves. Okay, that is a flat wave. Okay, but electron is moving around the nucleus. Okay, and in an atom is spherical, so that spherical wave is known as orbital. Are you getting my point?
The wave surrounding the atom is orbital.
Yeah, the wave surrounding uh, an atom is known as orbital.
Okay.
So actually, there is a equation given. Equation waves also have the equation. So have you heard of any function in mathematics? You know what is function?
Function, the mathematical function or the English
Yeah,
one?
mathematical function. Yeah,
No.
any function that like y equal to sine x or something, right?
Oh, like that. Okay.
Okay, it has different or a quadratic function also,
Yeah, in physics.
right? And a lot of functions, you know. So actually, waves can also be described. Wave of an electron can also be described in the form of a function, right? Is it clear or not? So actually, this and what are the two basic principles on which the wave mechanical model is based? It is based on the de Broglie's wavelength and it is based on the Heisenberg uncertainty principle. Both of these things uh, forced us to think that the electron is a wave. It is not a particle. And the wave is known as orbital. And the orbital can be described by the wave equation. This is known as Schrodinger wave equation. But don't worry, this is just I'm writing. You don't have to worry anything about it.
So what is that sign called?
Yeah, that is called psi. This is h. M is the mass of the electron. Pi is the constant. Okay. E is the total energy. V is the potential energy of the electron. And this psi is the wave function. Is it clear?
Yeah.
Wave function. So don't have to. This is the double differential. Like dx by dt gives the velocity along the x-axis. So d2x by dt square is gives the acceleration. So this is just like the double differential of the wave function along the x plus double differential along the wave function along the y plus double differential along z. So this is just for your viewing purpose only. No need to worry about it. Okay. So this is the equation which actually includes the wave nature and Heisenberg uncertainty principle, and the overall equation of the wave is represented in terms of x, y, and z. Because the atom is considered as a three-dimensional, just like a ball, it is having an x-axis, y-axis, and z-axis. Okay, so how that wave function is changing along the x-axis, y-axis, z-axis, this is how it is represented. But no need to worry about this equation. Okay, this is thus known as Schrodinger wave equation. Is it clear?
Yeah.
So wave function, what is the physical significance of wave function? It is just it will be just like sine x or something. Equations are there, right? And when you plot it, it will give you the how the wave of the electron look like around an atom, around a nucleus.
It's basically a graph.
Yeah, it is a graph, three-dimensional graph, and because you need to have x, y, z.
Okay.
Okay, so this is wave function.
So,
Yeah,
um, last year we used to have like a test series, something like that. Like they used to make a schedule, and then there's like a proper test of every subject on alternate days. So on like every topic and everything. So will we have that same this year too for 11th?
yeah, we can have that, no problem. We will be
When
having
will
that.
we have that?
Yeah, once the basic course is covered, we can go with that. Okay, and once you have this, because I'm taking some basic theory part. Okay, and some very few questions of NEET also I'm including as of now, right? So as we are done with some amount of course, we can start that also, right? NEETs are test series. So you are basically bothered about the NEET, right?
Yeah. Because it would be better if we had like the schedule and everything so I can like learn properly and everything like
Yeah, we can plan it. Just we can first we can complete few chapters, and then so that your school level thing is controlled, and then we can have that tests, right? So I will discuss and just
my state syllabus is the same as NCRT actually.
yeah.
But like the old NCRT.
Hmm. Old
And it
NCERT for 11th class.
yeah.
Hmm.
But then it's kind of different and the question pattern of the annual exams, boards and everything is different. It's way more easier than CBSE exams.
They are not easier. They are a bit difficult, right?
No, but then everyone said that it's way more easier and everyone always scores like 100% or something. And even in my relatives.
Hmm. Know what they are telling, that they are finding it easier or difficult than the board. I
They
mean
said
the
that the CBSE syllabus and the IP syllabus is same. IP syllabus is basically like the 70% of the CBSE syllabus.
Hmm.
But then there are some topics which have been omitted in the new NCRT, but they are still over there. But like zoology is way more deeper, detailed.
Hmm.
So like every single day we're having the state syllabus zoology classes and then also NEET syllabus zoology classes.
Yeah, okay. So we can have the quickly plan it. Okay, and just once we have some chapters covered, we can plan it. The
Yeah.
test series also,
The
right?
question patterns, like apparently they only asked like briefly, they even showed the questions and stuff. It's like
Hmm.
all brief, not like CBSE, like they asked from anywhere from the textbook. But then over here they're saying not to even buy the textbook, just learn from the notes. Because they asked
Hmm.
like only from like briefly.
Hmm. Hmm. Yeah. Okay. So we can do that, not a problem, right? And I will also, as I am already started including some neat questions in. This is the neat question which we took, right? This one,
Yeah.
this one. So we will have some similar neat questions also in our daily class. Got it?
Okay.
So So wave function of an electron. This is the wave function of an electron. What it is just like this is the nucleus. Okay. Actually, it is 3D, but I am representing it in 2D. Okay.
So which is
This is
the nucleus?
the nucleus. Okay. And suppose if you plot this wave function, at some distance it can have positive value, it can have negative value. Got it? Because it is a wave. Is it clear? This is the wave
Yeah.
function and the distance from the nucleus. This origin is a nucleus. So this is known as node. So you can have positive amplitude, negative amplitude. Is it clear?
Yeah.
As such, it has no physical significance for us.
So you didn't mention the Z plane.
Pardon?
You said there's gonna be like a three-dimensional plane, right? But then there's
Yeah,
gonna be
yeah,
X and Y.
it is going to be, yeah, I have represented for the sake of simplicity, I have represented only in one direction.
Okay.
Okay, but it is, I will describe the orbitals and I will give you the three-dimensional picture also. Okay.
Okay.
So this is the equation of the orbital, right? Basically. And how the orbital wave is changing with the distance from the nucleus. That is called wave function. Is it clear or not?
Yeah.
So each electron is having a corresponding wave function because it is a wave, means the equation of the wave. Overall, it is of no use for us because ultimately we are interested in finding the position of the electron. If it is a wave, we know that we cannot pinpoint, just like in the Bohr model, that this is the electron. Now we know that the electron is having a wave nature. Okay, we need to describe the wave and which function is there to describe the wave. It is the wave function psi. Got it? It can have positive value, negative value, or zero value. Is it clear?
Yes.
It is just like the amplitude of the electron wave. It is just like the amplitude of the electron. So amplitude is the how high the crest is or how deep the trough is. So what is the, suppose if you have more higher wave, larger value of wave function, so wave is having more value of psi, lesser value, negative value. Okay. So similar to amplitude of an electron.
So I didn't understand what amplitude was.
Amplitude, this is for a wave, this is known as amplitude. Yes, got it.
Okay.
And
The
it
increase
this
and decrease basically.
yes. So if it is a wave, it cannot have a constant value like this.
Yeah.
This one electron only, but it is actually distributed. This one electron being present at many places. At some place, this wave function is higher, some place it is lower. Got it? Is it clear or not? It has
But
no
how
physical
can one thing be
significance.
present everywhere?
Yeah, this cannot be imagined by a normal person. We cannot imagine.
But then
Is
how
it
do
clear?
we know that it's present everywhere?
Yeah, actually, Davison and Germer experiment was performed. in which the electrons beam was targeted on a nickel crystal. Just like when you put light on a crystal, it diffracts and refracts. Okay, suppose if you take some diamond like crystal and you put a torchlight, what happens in the room? You see a lot of marks. Okay, it diffracts and refracts. So similar way, electron is a particle, and when the beam of electron is targeted on a nickel crystal, you will see refraction and diffraction happening, just like it happens with the light waves. So it represented that the electrons are waves. Got it?
But then it's just an image, right? Not the actual thing.
Yeah, it actually, yeah, it is the suppose if it is behaving like a particle, we should get the electrons here only. But it is, you get a wave pattern, a diffraction pattern similar to the light waves. So that indicates it is having electron, which is a particle. It is having a wave-like character. Got it? So, but normally it is very difficult to imagine because we don't see it in day-to-day life of it. So, but we can imagine there are some mistakes, some saints, right? We know that they can travel. Okay, they may be having this kind of uh, their wave nature, and some places they can appear at another place. Okay, just like I'm trying to give you an example.
So it's not real.
Yeah, it's not, it is insignificant for large objects, because large objects will have very small wavelength, but it become quite significant for small objects like electrons. Is it clear?
Okay.
So this is a wave function, and basically tells us where the wave is, what the amplitude is, at how much distance. So what is the value of wave function at very far from the nucleus? Very far from the nucleus, what will be the value of the wave function? It will be zero,
Yeah.
because each atom has its own size, each shell has its own size, and the electron is present in that, its wave is present in that region only. If we take a larger region beyond that limits, its wave will not be there. Okay, so what is the value of wave function at a very far
Zero.
distance? Zero, because there is no wave at all. Is it clear?
So there's no wave inside the atom, right? Only surrounding the atom,
No, there is a wave inside an atom around the nucleus. Is it clear?
around the nucleus.
Yeah, around the nucleus. This is the nucleus, and how that is changing. Wave is changing. I have shown it only on one side. Actually, it is three-dimensional. Okay. So,
Okay.
but this wave will not keep on continuing at a very far distance. Okay, this has some limit. As you move farther, the wave is going to diminish and it will completely become flat. It is just like you throw a stone in water, waves are being generated, right?
Yeah.
And those waves, what happens? They don't continue up till very far distance, they just subside after certain point, just like that. Then you have psi square. Okay, so you have a plot of psi square also. And if you plot psi square, these are the graphs, actual graphs I am not telling you, right? Actual, so psi square is, it will have positive value. Is it clear? So it is the
Okay.
square, it is just like the square of the amplitude. It will have just positive value or zero value. And in conventional, in wave nature, in wave theory, in light waves, the intensity is proportional to amplitude square.
So what will the wave function for the upper graph be?
No, this is, suppose you are having this
No, the
as a,
upper one above it.
yeah, this is you are having a graph for psi, right?
The down one you said it will be positive, but what about this one?
No, this is the wave, it will have positive and negative values, right? It is a
Okay.
wave and zero value also. And this is psi square. Okay. So it is just like the square of the above graph. Are you getting my point?
So the y is basically the psi we are writing in the graph.
Because psi is the amplitude of the electron wave. Okay.
Yeah.
But that is just the electron wave. Actually, we don't know. We are interested in finding the electron. So we need to make a graph for psi square. We need to know the value of psi square.
Okay.
It is psi square is the probability density. Don't worry, it is going to be very easy. Just listen to me. Okay, then I will reconnect all the points. Okay. Psi square is the probability density of finding electron in a unit volume. So in light, first listen to me what happens in light. Suppose if there are two light waves, one like this, right? And another like this. First,
Luminescence.
yeah, first option and second option. First option is having lower amplitude, second is having larger amplitude. Okay. Do you agree with it?
Yeah.
And intensity of the light is proportional to amplitude square as per the wave theory. Intensity is proportional to square of the amplitude. So which light is going to be more bright and what is the intensity? Means
Second
intensity,
one.
yeah, how much brightness it is having, how much light is present. Okay. Intensity is per unit power per unit volume, how much energy we are getting. This is for the light rays. Okay. So psi represents the amplitude of the electron wave. Psi square is the square of amplitude. Just like the light waves, where the in the light wave where the square of the amplitude was giving us the intensity of the light waves, the square of psi is giving us the intensity not of the light waves, but this is the wave of electron. So it is giving us the intensity of the electron. Intensity means how much density of that electron is there per unit volume. Intensity in light is brightness. How much energy per unit volume is there in the light. Intensity in case of electron wave, psi square is giving us the probability density of finding electron in a unit volume. It tells us how much density of that electron is there in a unit volume around the nucleus. Why we are talking such weird things? Electron is just this. Why I'm talking about the density of the electron in a unit volume? Can you correlate with it? Because now we need to shed this picture. This was the particle nature. Is it clear or not?
Okay.
Now we know that the electron is not the particle, it is a wave. And if it is a wave, it's not present everywhere equally. Got it? Is it clear? Is
Okay.
it everywhere equally?
No.
It is. So where can you tell if this is the electron wave? Where can you, where so this is just one electron wave which is being spreading at many places, but out of all the places, can you tell me, by just looking at this rough graph, in which section the you have more presence of electron, the density of electron is more?
The
The
second part.
this part I will divide it into three parts. This part, first part, second part, or the third part?
Second part. Because it looks like
Yeah,
it has more amplitude.
yeah, more amplitude. So square of the amplitude. So just like in the light waves where their amplitude square was giving the intensity of the light, similar to this, if you square the amplitude of the electron wave, you are going to get the intensity of the electron. Means you are going to get the probability density of the electron, means the density of the electron per unit volume is going to be more wherever you have more value of psi square. Is it clear?
Yeah.
Got it? So have you understood the significance of psi and psi square? Psi square is the probability density and it will always have either positive value or zero value. It will not, it will never have negative value, because when you square a negative number, so psi was having a positive and negative value both, but psi square is having only positive values, okay, because the square of a number is positive. So basically when you plot this in three-dimensional space around the nucleus, okay, you get the uh, density of the electron around the nucleus. So you get, when you plot this, you know that the one electron, earlier we used to put electron like this in orbit, right? Now it is not the case. Their orbit only radius was needed. Now we need to put the value. So this is the nucleus. We need to completely plot, okay, by putting dots. So these dots are somewhere they are more dense and somewhere they are rare. Okay.
So the shells are basically just dots and not.
Yeah, this is actually, yeah, this is the whole first. This is the orbit. This is the orbit. Is it clear? This is very very important. Without it, you can't survive. Got it? But very easy also. But when you try to look at it, okay. So I can show you some orbitals also. Okay. You are having pictures in the NCRT also, right? Just hold on for a second. Let me show you the orbitals. These pictures are there in your NCRT also. Just hold on for a second. So you have wave functions, and these are just like the graphs. So have you seen the graph of sin x? How it looks like?
No.
Sin x is just like this, because sin 0 is 0 degree, sin 90 is 1, sin 180 is 0. Okay. So just like this,
Oh,
this
like
is,
that. Okay.
yeah, okay. So but that is sin x graph is very symmetrical. Okay. But this graph is actually like the wave only, but not as symmetrical as that. Okay, these are having a complex equations. Is it clear? So let me show you the picture of the orbital. Just a second. How they look like, and how these orbitals are. How we got these orbitals? Can you tell me? These are the orbitals, right? Atomic orbitals. So how you got these orbitals? Yeah, Maha, can you tell me?
What? Can you repeat?
Yeah, how you got these orbitals? What are these orbitals? These are the wave functions
Basically,
of the,
waves, right, present in the atom.
yeah, waves. So this was the actually older model, right? Now you don't use this older model. You instead plot the waves. Got it? Is it clear? Just a second. Let me. So now the electron is represented as a wave. It is just like a cloud around the nucleus. And how that cloud is plotted by by plotting the value of wave function psi and psi square around the nucleus. Is it clear? Atomic orbitals, right? So you have these kinds of atomic orbitals. Right? What these different color represents? So you have orange color and you have, this is the whole cloud, but the cloud is different and there is a gap also. Can you see in the middle?
Yeah, the orange color there.
Yeah, there is a gap between these. So there is a, this is a wave. Okay, so wave can have positive value, then it will have negative value. Okay, and
So
in
what is
between
the wave over here?
the
The
wave, this
orange color thingy?
orange and blue, the different color represent different sign of the wave.
They are
And
perfect
in between,
surface on.
yeah, actually it is a three-dimensional wave which is emitting from the nucleus. Okay, and it is having a positive value, it is having a negative value. Between that value, if you see a small gap ring which is empty, there the wave is zero. That is called node. Is it
Okay.
clear? Positive value, negative value. Is it clear? So these waves are not like the normal waves, right? They are spherical because atoms are spherical. Is it clear or not?
But then you said they were in dots form, right?
You can represent it in this, right, by showing the value of the wave, the amplitude of wave, by showing, by putting dots. More dots means higher value of psi, of psi square. Lesser density of dots means lesser value. That is called electron dot density diagram, right? That is
So it's
also,
only dots when it comes to density.
yeah, there are two ways to represent an orbital. One is electron dot density diagram and the boundary surface diagram. This is the representation. Can you see it? Electron dot density diagram.
Yeah.
So wherever you have, you put the values of psi. Okay, more psi means, so closer to the nucleus, you can see there are more density of the dots. You can see, got it. And as you are moving, the density of the dots is becoming less and less. Is it clear? Like this one. Can you see the electron dot density diagram?
Yeah.
These are the plots of psi. This is the plot of psi or psi square, right? The different colors is actually, what is this blue and red color? This is the wave
Density.
changing sign. Yeah, wave changing. So somewhere the wave is having a positive value, psi is having a positive value. Okay. Then it is having a negative value. So positive value, if it is represented by blue color, the negative value is represented by red color. And in between, you can see a gap between the two colors. That is a node. Is it clear? I will discuss in detail the types of the nodes also. Okay, these are the waves. Can you see? Can you see the node?
Node.
Node is the region where the value of psi is 0. Got it? Can you see it here?
It will be the
Can you
furthest,
see
right?
the empty?
The circle.
Yeah, it can. Yeah, empty circle, empty shell-like thing, because it is atom is like a ball. It is just
So
like
what's
a
the white
coconut.
part over here?
White part is that different sign, blue and white. The two positive and negative sign are represented by blue and white. Got it? Is
So
it
the
clear?
positive will be near the nucleus and the negative will be outside.
You can take any one. That is not a problem. No, that is not the charge. Got it?
Then what is?
No, it is just the presence. It is showing the presence of electron. Okay, the wave of the electron. Whether the wave is
Okay.
more means more at present, that electron part of the electron is present more over here if the wave is more. And if the wave is very less, right? Amplitude mean that part of the that single electron. This is just one single electron. Got it? But it is
Oh,
not
okay.
present at one.
So the blue is like the waves where the most of it is present, and the
Yeah.
clear part, the clear
As
circle, zero.
yeah, the wave function changes sign. Yeah, that is the node where it is, because it is having a positive value and or higher value, and then it goes below the x-axis by becoming 0. That is called node. And as you are moving, the intensity of the dots is decreasing. Can you see it?
Okay, I understand now. So it became so like, the
Got
more
it?
further it becomes from zero, it becomes negative. Okay.
Yeah, negative, or you can say if you start from negative, it become positive. Negative, positive doesn't matter. Only the higher and the lower value matters. Closer to the nucleus, the wave function is having higher value.
But the
And as you
higher
move
means
away from the
positive, right?
nucleus, yeah, normally it is positive. You can start with positive because that's the normal convention which we follow. And suppose if there is a node in the middle, it will become 0 and then it will become negative value. There can be multiple nodes also, right?
Yeah. So what about that image, the
Is it
middle
clear or not?
image?
This one?
Yeah, there's like five different colors of rings.
This is actually, this is wave which is many times changing its sign. So there are more nodes. We will find the number of nodes also. Got it. You will be able to do it very good. It is very easy,
Okay.
but starting is difficult. So now we understand this is just one electron, right? This is just
Yeah.
one electron, right? One electron. But the wave has having this kind of pattern. And I should not draw, but though I have initially drawn it like this, like a rope. Is it clear? But actually, it is not a rope. You need to consider it around the nucleus in a three-dimensional space. So this is the
Does
wave
the
of
wave
the
change
electron.
uh, uh, to the particle, like if the compound or whatever it's in solid, liquid, or gaseous form? Does the wave change?
No, there is not a wave change, because solid, liquid, and gas, the atoms remain same. Is it clear? This is known as electron dot density diagram, where you represent whether the wave is more or less by actually putting the dots. Is it clear? Sometimes you don't put the dots. This is electron dot density diagram. Okay, this is just one electron. Is it clear? But the wave pattern is like this. This wave is not like the normal wave. Okay, now don't think.
How
This
do
is
we
like
know
a
that the
wave.
wave pattern is like this?
How do we know? Because there are equations. When you plot these equations are very complicated, but you don't need to get into all these things. But
Okay.
without that, without knowing the equation, we have the very easy thing by which you can quickly tell how many nodes will be there. Okay, what will be the shape of the wave. Okay, you can predict all the things. There is a boundary surface diagram also. Boundary surface diagram, doesn't let you inside. Suppose in the biology, when you draw the diagram of a heart, there is a boundary surface diagram which represent the heart from outside, and there is a cross section diagram which represent the four chambers. Got it? You might have done it
Yeah,
in your time. So
the external
similarly,
and the
there is
internal
a boundary
parts.
surface. Yes, for kidney also, or for every organ we do it, for leaves and all, stem and all, right? So in the chemistry also, that electron wave is known as orbital. Okay, it can have positive value, negative value. The wave function can have positive, and wave function is like a function which describe the electron wave. Is it clear now? It can have
Yeah.
positive, negative values, right? And it can be represented by electron dot density diagram, where you represent it by plotting the dots. More dots mean the more part of that single electron is present over that region. Less dot means lesser part, means less
So
density of
this
that electron.
orbitals are surrounding the electron or the nucleus.
Yeah, yeah. No, no, this is orbitals are the electrons only. Their waves are known as orbitals. They are surrounding. They are present in an atom and around the nucleus. Okay. So the center will be the nucleus. Is it clear? So you
Okay.
can have different waves. These are all electron dot density diagram. Boundary surface diagram will just give you the outer shape, just like a watermelon, which will tell you that it is green in color and some patterns on it, or sometimes it is dark green in color. When you cut it, you know that there are seeds and there is a red color and all. Okay, so this electron dot density diagram is like the cut, that cross section. Okay, and the
So
boundary
then what's
surface
happening
diagram
to
is just
shells? Shell 1, shell 2, shell 3, shell 4 that we
yes,
learned.
yes, 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 exactly. So that boundary surface diagram is just like the outer shape. They give only the outer shape.
Oh, it's the
They,
outside part we learned.
yeah, they give only the outside part, right? Is it clear?
Okay.
So now I hope it is clear what is orbital. So what is this electron wave? Normally we represent it in a very basic way, but actually it is not a basic rope kind of thread kind of wave. It's a three-dimensional wave. Okay, psi is the wave function, which is an equation. Okay, and psi can have very complicated equations, so don't need to get into the equations. Okay, just I can show you a lot of equations are there. There are various functions are there, so you don't need to remember the equations. The equations. Here. So, but without the equations, also I will tell you the thing by which you can figure out what is the uh, how you can determine the shape, how you can determine the node. These are the mathematical equations for, because it is, after all, it is a function. Okay, and how you got that function? By solving that Schrodinger wave equation. As of now, you don't have the solutions or solution in your syllabus, so we will do it by other means. Is it clear? Science
Okay.
as per is clear. Okay. Now the psi and psi square is we are not going to plot the numerical these functions. Okay, first of all in chemistry, because that is a mathematical part. We have some quantum numbers, and with that quantum numbers actually will make the solution of the Schrodinger wave equation meaningful. You are already aware of some of the quantum numbers. So quantum numbers, actually when you get the actual functions, those actual functions, you can need, for plotting them, you need to put the value of certain numbers and those numbers help you to plot the wave functions, and those numbers, or here we will say, they will describe, these quantum numbers will describe the orbitals. Okay, and there are four quantum numbers: n, l, ml, and s. Three quantum numbers are linked to Schrodinger wave equations. Okay, these quantum numbers actually help to make the solution of the Schrodinger wave equation meaningful. Okay. When you put these numbers, you are able to actually able to plot the psi or psi square. Is it clear?
Yeah.
Normally in your junior classes, when you solve the two equations, okay, when you solve two equations, you get the answer as x equal to 2, right? Or y equal to 1, like that kind of solutions.
Yeah.
But in this case, you are, when you are trying to plot this wave functions, you need to put certain numbers to plot them correctly. Okay, it is not just a simple psi equal to 1 or 2, that kind of thing. You need to put some quantum numbers into them to make their solutions meaningful. Is it clear?
Yeah.
These quantum numbers, there are three quantum numbers which are derived from wave equation, and they are used normally. With these quantum numbers we are able to plot, but actually we are not handling those equations as of now. So we will not plot directly, but indirectly we will see that how these quantum numbers tell us something, what they tell us about the orbitals and how the orbital look like with these quantum numbers. Okay, so these quantum numbers, they are used to predict the orbitals or wave functions. Orbitals are actually wave functions.
What do you mean by predict the orbitals? Like,
Actually, when you solve that Schrodinger wave equation, you get different psi. You need to plot them. Electron can be in first orbit, second orbit. Got it? So each electron,
the
suppose if
graph.
you are, yeah, suppose if you are having 11 electrons in sodium, so where those 11 electron will look be present? Two in one s, two in first shell, right?
Yeah.
And remaining 8 in the second shell, 1 in the third shell. They will have different wave functions. Is it clear? All the electrons are not present in the first shell. First shell can hold only 2 electrons.
2 electrons.
8, and the second shell is having 8 electrons. Got it? And the third shell is having how many
8.
electrons? One. Third shell
Like the
in
largest
sodium.
capacity it can hold.
Yeah, yeah. So actually, so these electrons in sodium will have different wave functions. They are present in sodium only, but they will have different wave functions. Got it? So I need so if there are 10 electrons, I need 10 wave functions. Okay, but I'm not going to write it mathematically. I'm going to express them in terms of quantum numbers. So quantum numbers make the solution of the wave Schrodinger equation meaningful. in order to get the meaningful, or in order to physically understand that what that wave function is, okay, what it represent, we need to understand the quantum numbers. Okay, they are used when the values are put in that functions, you get the actual shape of the waves. Okay, but we are not going to put that proceed in that manner. Instead, we will follow a different approach which is much easier. This is known as principal quantum number. Got it? Is it clear?
Yeah.
This is known as principal quantum number. This is the quantum number uh, and all the students are aware of this quantum number. Got it? In your junior classes. So you have a wave function. It will be a complex mathematical equation. It will have some n, l, ml in it. You put these values and you get the quantum number. You get, when you put these values of n, l, you get the specific wave function for each electron. Got it?
So what do you mean principal
So we
quantum
need
number
to
like?
know, yeah, principal quantum number. You already know, and all the students know it by some other name that is known as shell number. So you know it or not? Tell me. From your
Yeah.
ninth class, right? So that is the shell number. So instead of solving all those mathematical equations, we will try to figure out how that waves look like with the help of this quantum number. And we can think that, okay, if the quantum number is 1, means the electron is present in 1 per shell. Okay,
Oh, like
what
that.
value?
Okay.
Yeah, so they are known as quantum numbers. But in actually, there these numbers are put in that equations, and you get the functions for each electron and you plot them around the nucleus. For sodium, 11 wave functions will be there. Got it? So principal quantum number n equal to 1. What values can it have? You know already, this
The
is the
first shell can
most,
only hold like maximum 2 electrons, and then the
yeah,
second, third, fourth,
easiest
fifth
quantum number.
hold 8.
This represents the shell number, yes. And it can be represent, it can in the n has a zero value. Can it have zero value? Can the shell number be zero?
No.
No, it cannot be zero. You have first shell, second shell, third shell, fourth shell, right? Like that.
Yeah.
This first shell is known as, it is also represented as K,
Yeah.
L,
K, L, M, N.
M. They are represented by capital letters, N, right? So first quantum number is, what does it represent? The shell,
First shell.
right? Second one, second n equal to 2, represent the second shell, n equal to 3. N is a symbol for the principal quantum. Normally, in the equation, you have the n, you put 1, 2, 3, and you get the wave functions for the first shell, second shell, third shell. Got it? But that mathematical part, we are not going to do it here. Is it clear or not?
Yeah.
Understood? So these wave functions are mathematical equation. There we put these numbers to get to make their solution meaningful to us. Normally we are not going by mathematical equations, we are going by other way, but we will reach at the same point. What else this n denotes? Suppose if you are having a higher principal quantum number, what it means?
The wavelength is more.
Yeah, higher. No, no. Now in a common man language, we will put
Orbital.
higher, higher the value of n. So for a common, the I will represent more n means more what?
More N
Larger
means more.
yeah, the higher the shell number, larger will be its size, right? Higher the value of n, more will be.
So is it really important to learn the first 30 elements in the periodic table?
Yes, it will be very comfortable for you if you remember the first 30. Right? So higher the value of n, more will be the energy of the electron. Right? How Bohr represented these n as
Size
circles.
and energy is same overview.
Pardon?
You said size was right. More will be the
Yeah,
size
size.
of the.
More will be the size and more will be the energy. So higher the value of n, higher the shell number, more will be the energy of the electron, and
Okay.
larger will be the size of the shell. But Bohr used shell. Now we are going to use orbital. Bohr used the term orbit like this. Okay, now we know this is not an orbit. This is a cloud, whole electron cloud that we've. Okay. So higher the value of n, more will be the energy of the electron, larger will be the size of the orbital. Is it clear? So will the first shell have the larger orbital, or the second shell will it have the larger orbital, or the third shell will it have the
The
larger
N
orbital?
shell will have
Yeah,
the.
yeah. As you move away, as the n increases, the size of the orbital keeps on increasing. Got it? I hope this is clear to you. Okay. So, but in Bohr didn't know all this about electron thing. So Bohr represented them as circular shells, and Bohr also found the value of the energy also. Okay, that is minus 13.6 Z square by N square electron volt. Okay, with this quantum number, which in Bohr model it represented the shell number. So now also we know that it represents the shell number, but we know this is the principal or the main quantum number, which tells us what should be the size. Okay, which gives a rough idea about the size of the orbital and the energy of the orbital. Okay, and Bohr also calculated the energy for the for each n, right, for electronic species. With the value of n, you can also find the number of electron present in each shell. So what is the number of electron present in each, for each n? Maximum number of electrons. Maximum number of electrons which given shell can hold. How much they will? That you know from your 9th class. Got it?
Yeah.
So first shell, K shell will have how many electrons?
2 maximum.
Maximum. Yeah, maximum 2. For hydrogen, just 1, or helium, it is 2. Okay.
All the other
K
shells it
shell,
will be 8 maximum.
no.
For and all that, it's 8, right? For the maximum.
No, they can have more. But in junior class, we tell that it is 8. Okay. L shell, the second shell. Got it? This shell was used by the Bohr, but now that we know that this is whole group of energy levels. Okay. N equal to 2, right? How many electrons the
Yeah.
second shell can have? 2 into 2 square, right? So it is going to be 4 into 2, 8. M shell can have how many electrons maximum it can hold? 2 into
18.
n square. Yeah, 2 into n square, 3 square, right? 9 2s are 18. So third shell can have maximum 18 electrons. Is it clear? So each shell can have maximum 2n square electron. This shell is actually represented by circle by board, but now we know this is not a circle. This is actually a group of
But
electron
when we
cloud.
wrote about like the shells in the, like for example potassium, we wrote as like the electronic configuration as 2882. But then why wouldn't we write as
2
18?
8 potassium is which element? 19th element, right?
Potassium.
8 2, because they are not filled in regularly. It is not that first you will have 2 electrons in first shell, then 8. That is there, but M shell is not filled regularly. So as the M shell start filling up, N shell also start filling up. Then you have the M shell being filled. Got it? Is it clear? So it's not that you will have 8 electrons only, but actually after 8, you will have this N shell being filled up. Then again you will have this. You will understand all the rules which will govern the filling up of each shell, right? Your concern is genuine, but maximum electron 18, but they are not filled regularly. That's why you concluded that it can have only 8 electrons. No, it can have 18 electrons. Got it?
Okay.
M shell. So this shell actually in Bohr actually. So in M shell, how many different orbitals will be there? How many different wave functions will be there for a M shell? Or
18.
for K shell, yeah, 18 wave functions will be there. 18 different shapes of the waves. 18 different values of the psi. Is that clear? So that whole group, because there are 18 electrons, for each electron, it is not a simple dot. It is just a whole electron cloud. Got it? Is it
Okay.
clear or not? So it will. So how many orbitals will be there? We can, next thing which we can figure out number of orbitals equal to n square. So each orbital can hold 2 electrons. So n square orbital will be, right.
Yeah.
In third shell will have how many orbitals?
9.
9 orbitals. 18 electrons will be there. Got it?
But then
Is
over
it
here
clear?
you only wrote n square. Oh, okay,
Hmm.
okay. I understand.
Yeah, each orbital will can have maximum 2 electrons. So to find a number of electrons, you multiply by 2. This n can also tell us the value of classical angular momentum. Classical angular momentum when you consider the electron to be a particle moving in a circle with radius r and mass
I know
mvr.
angular momentum, but then what do you mean
Yeah,
by
angular. Yeah,
classical?
classical angular momentum means yeah, it is same as angular momentum. Classical means actually it is just like you treat it as a classical theory where particle, you treat it as a particle. So you need to multiply the mass of the electron. You need to get the velocity of the electron. You need to get the radius of the electron. You need to multiply them all. And what will be the value of this classical angular momentum? From where will you get all these values?
Some
I am not
calculate.
giving you, but this was discussed in Bohr model that the angular momentum classical, that was classical because that was not, that was by considering the electron to be a particle that was equal to nh upon. Is it clear?
Yeah,
So that momentum is nh upon 2 pi, right?
yeah,
First shell will have momentum h upon 2 pi. Now you can calculate h upon 2 pi. H is constant. Second shell will have angular momentum electron as h upon pi. Third shell will 3h upon 2 pi, like so on. And this shell is actually represented by a simple circle. And actually in classical model we put a lot of electrons in this. Suppose 8 electron like this. Okay, this picture is incorrect now. This was used to be followed in 9th class, but not in class 11th. This is, let's say, second shell. So second shell will have 4 orbitals. Okay. And 4 orbital, each orbital 4 wave functions, each will hold 2 electrons. Got it? So we need to get some more details to describe the orbitals present in the shell. And with for each n, there is another number which is linked to n. That is the secondary number. That is, that quantum number is known as L. Okay, this is known as subsidiary quantum number, azimuthal quantum number. Secondary quantum number. This is also known as angular momentum quantum.
azimuthal means secondary.
Yes, azimuthal. Actually, this is the word is derived from that solution of the wave function. So as of
It's a
now, you
Latin
can
word.
know from azimuth means from the top zenith, how much angle, right? And angular momentum quantum.
No, like which language is it? Latin, right?
Oh no, in English also we use azimuth, azimuthal angle, right? In trigonometry also we use, right?
I never heard of it.
Got it?
Yes, sir.
So actually, first of all, for each shell there were so many electrons, and now we know they are not present in a one shell. Within the shell, there are subdivisions, okay, into subshells. So it tells us about the subshell. So in junior classes, we used to put 8 dots in one circle. Now that is not true. Within the shell, there are subshells present.
What do you mean by within the shells? Like in the
Pardon?
same shell?
Yeah, actually, in your ninth class, how you used to put those 8 electrons in second shell, right?
Randomly, right?
Yeah, you used to put it to draw very clear diagram, right? Making a circle,
Yeah.
and now we know that electrons are not circle, they are not particles, they are clouds,
Just
electron
dots.
clouds. Okay. Yeah, we used to put dots in junior classes, and everybody loved to draw these structures with different colors and color pencils, right? So now we know that life is not so easy, it has become very difficult. These electrons are actually present in subshells. Got it? Those whole group of subshells is put under n equal to 2. Are you getting my point?
Okay.
So n is the shell number. Okay, once you study the complete thing, it become quite easy. But while you are studying, it appears that it is so difficult that you have never seen such a thing. Okay, but
Yeah,
believe
it's
me, it is going
confused.
to believe me, it is going to become very easy for you, and you will be expert. Okay, so shell indicates the rough. It gives the rough idea of the size or the distance of the orbital, how big an orbit, how much energy the electron is carrying. In Bohr theory, it used to represent the circular orbits, first orbit, second orbit, and we used to put all those electrons in that orbit, and each orbit can hold maximum 2n square electron. Second orbit can hold 8 electron. We used to put them like that. Okay, and now we know that it is not like that. These electrons, 8 electrons, are present in the subshells. Okay, subshells is not that you have a shell and within that you have a subshell. Actually, these are grouping in terms of energies. So these subshells are represented by L. Azimuthal quantum number, subsidiary quantum number, secondary. Subsidiary also it is called subsidiary quantum number or secondary quantum number, because it is not the principal, the main quantum number, it comes after it. Okay, for each n, the value of start, because it is junior quantum number, its value start from 0, 1, 2, and goes up to n minus 1. Is it clear?
Yeah.
You need to remember this. So for, and the each, this is the number code for each subshell. Like if we are in a city, we have the name of the city and we have the pin code. Okay, similarly, you have the name of the shell, KLMNOP, you have the number also, shell number 1234. Within the shells, they are subshells grouped together within a shell, and they are represented by alphabets, and they can be represented by numerical numbers also. Okay, the
But over
zero
here,
L equal
subshells are
to,
represented by numbers, right?
yeah, subshells are also represented by numbers and letters, just like the shells which were represented by 1, 2, 3, 4 KLMN. The subshells are represented by the number which starts from 0 to, and it stops one value before n. Okay, S, P, D, F. Getting my point or not? So these are the
Yeah.
subshells. Okay, how many subshells can be there? So these are the, basically we are ultimately get not put that 8 electrons in a circle. We are going to group them in subshells. Is it clear?
Yeah.
So this is n equal to 1 means K shell. what will be the value of L and how many different values? L will start from 0 and goes up to n minus 1. Is it clear or not?
Okay, I get it. We just have to subtract one from the shell, right? That will be the
Yeah, so n minus 1 is 0. So first shell is having just one subshell. Only one subshell is there, and that is represented by 1s. Is it clear?
yeah.
Let's move on to second shell, L shell. What is the value of n? N
2.
is
So 2
to
minus 1, 1. So
what
subset
is
shall be 1.
how many different values L can have? L can have 0 and 1 value. There are two different values and they are 0 and 1. Are you getting my point or not? So value of L starts from 0 and goes up to n minus 1 for each specific n. So
So why is
second
0 being
shell,
added over here in the second
why
subshell?
0? Because yeah, you will not be able to understand until I give you that mathematical functions, that why you put 0, why you put 1, right? Why not
Yeah.
minus 1 and 1? Okay, that meaningful thing is going to come only with the mathematical equation, which we are not going to do. Okay, so but actually you put the mathematical, these are the mathematical equation for psi. You put the value of n, then you put the value of L, so you get that particular subshell. So 0 means, so always remember this. Okay, when we do counting, we start counting from this division 1 2 3. Okay, so for subshells start from this. Okay, this is 0. Are you getting about 0 1 2 3? So S P D F, right? So the
Yeah.
second shell will have two subshells. Okay, and they are S and P subshell. L equal to 0 is S subshell, and but they belong to the second shell, so they are represented like this: 2s and 2. Are you getting my point?
So
What was the
3,
third shell?
0,
Third
1,
shell.
and 2 will be included.
No, it is subsidiary quantum number. So just imagine that stops one position before n. It stops at n minus 1. It starts from 0 and stop at n minus 1. Got it? Is it
Okay.
clear? M 0 1 2. Got it? And the M shell, third shell will have 3s, 3p, and 3d subshells, right? So I hope this is clear. Can you tell me
So
quickly? Fourth shell will have how many subshells?
0, 1, 2, and 3. And then the
The
values will be
value
like
of L is
4s,
0, 1,
4p, 4t,
2,
4f.
3. Yeah, it will have 4s subshell, 4p subshell, 4d subshell, and 4f.
4f.
Right? Got it?
Yeah.
Is it clear?